What's going on, everybody? This is the Space and Rocket Review. It is March 16th, 2026. I'm EJ for the Space and Rocket Review. I got a bunch of small stuff here, mostly just catching up from last week, because with last week's tank watching schedule, we didn't really get to a lot of interesting things. So party on, mate. Party on, Garth. Yeah. It's Space and Rocket Review. Party on. Excellent. I would grab my guitar, but I don't have it. My dad has the axe right now because he's re-intonating the guitar. He's re-intonating it. All right. So, let's get to it, shall we? Didn't he do that like 3 years ago? I don't know. I don't remember. Or is that the bass? I don't know, bro. I don't remember. Leave me alone. All right, so we're going to start off here with Relativity, with a Terran R update. This was from, they posted this last week, so let's get to it. Of course, we can't listen to it because, you know, YouTube will get mad at us, but this is the February update that we're watching in March. Closed captions. Let's dive in and take a look at key progress across design, build, test, and launch. This month, the team released an additional 1,826 flight components. The Stage 2 shipping assembly and fluids top-level assembly are now fully released, unlocking final integration work as the second stage tank nears completion. The team completed high-fidelity... Whoa, look at that. High-fidelity scale-resolving computational fluid dynamics analysis of the grid fins, accurately predicting unsteady aerodynamic loads. Accurately? Compared to what? The ones that you've flown, or...? Second stage harnesses and composite raceway covers have been built, and fluids work is progressing. The common dome baffle is being installed, and a composite overwrap pressure vessel leak test was successfully run. Integration roll rings have been installed to support upcoming handling and detailed integration operations, and the second stage headband is complete and ready for vehicle integration. Integration work also continues on the first stage tank. Weld buy-offs along with paint touch-ups were completed. Instrumentation brackets were installed, and exit holes and pass-throughs were machined. On the dedicated Stage 1 qualification article, all barrels have been manufactured and are now being assembled on the circumferential friction stir welder. On the thrust structure, the outer ring and inner ring are being installed, and the first two outer engine feed lines have been welded. Flight software for the thrust structure was released, and avionics boxes are being delivered on the path to low-voltage checkouts. On the inner stage, the forward barrel underwent additional mechanical assembly, including tooling hole plugs and the access door. In parallel, the team drilled the lift point and holes and installed brackets for composite overwrap pressure vessels on the aft barrel. But we're not just focused on Terran R's maiden launch. Production is underway for Terran R's second flight in parallel, with the thrust structure build progressing, first stage barrels being manufactured, underscoring our focus on scalability. Propulsion manufacturing continues at pace with additional first stage Terran R flight engines. Process improvements, additional machine shop capacity for new in-house... This closed captions are going very fast. New in-house capabilities are increasing output, further supporting our ambitious ramp rates. Meanwhile, Mechanisms is at work progressing with the thrust vector control actuators and pre-valves in production. In avionics, the Stage 2 hardware-in-the-loop build progressed, paving the way for vehicle hardware-in-the-loop testing. Increased engine production is matched by faster activation times and enhanced operational rigor for propulsion testing. At NASA Stennis, ensuring engines move efficiently from build to test. Acceptance testing of first stage engines continues alongside development testing for the second stage Aeon engine. Infrastructure development on site continues on the old A2 test stand. The live ring structural interface that supports the stage while allowing controlled movement during testing operations was lifted into the stand, and construction of the plume progressed ahead of the diverter installation. Framing for the nearby hangar is complete, laying the groundwork for the next phase of construction at Cape Canaveral. The launch site is visibly coming to life. Insulation and siding work continue on the horizontal integration facility, and lightning protection system piles have been installed 98 feet underground, providing a secure path to safely dissipate lightning strikes away from the pad and vehicle. The $1.1 million pound launch mount and transporter erector upper strongback arrived with insulation and outfitting work to follow. The engineering support building has been advancing rapidly, with steel framing complete and the outer shell added. That wraps up this month's update. All right, now I want to go back and look at the pictures because I was reading this the whole time. That engine does not look as clean as Raptor 3. Yeah, it's a little more conventional, we'll say. It's interesting that they've gotten their analysis done on the grid fins, you know. Because they say the team completed high-fidelity scale resolving computational fluid dynamics analysis of the grid fins, accurately predicting unsteady aerodynamic loads. Usually you need to fly them to do that, but all right, whatever. Nice. Yeah, okay. Yeah, that one's not finished. You're missing a couple of winglings there. There's the inboard COPVs with their covers on, so you don't bonk them, because bonking them is bad for them. Those are the processing rings. Yep, you do that. You put these on during final assembly. It allows them to rotate it on a giant rotisserie. See your last message. I believe accurate in this case means better estimates on fluid flow computation. Yeah, I'm wondering what that's accurate to, right? So there's a tank forward skirt right there. They call it a headband. These are all mounts for different lines or avionics. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I currently look like Ness from Earthbound. Okay. Huh. They're using tank. They're not. That's a weird way of doing that, dudes. But, yeah. That's some pretty complicated plumbing. But then again, this thing has a lot of engines in the bottom. Ooh, that's very nice. Look at that. Spin formed, I think. Beardless EJ is definitely weird to come back to. All right, how about I make it a little bit weirder? So this is their engine section. Yeah. Oh, that guy's TIG welding. He's TIG welding some pipes. There we go. Sargonized in pairs on a hexagonal pattern, but it's missing 2 ports. Yeah. Interesting. These are computers. Okay, so we got interstage here. That's the interstage. This is the structural carrier that connects the first and second stage. Oh yeah, look at that. All billet. the whole thrust structure is all billet or anodized billet aluminum. That's nice. Very nice. This is the Flight 2 thrust structure. It's being built in parallel. Very nice. Yep, those are AON-R engines. They're still using the 3D printed-ish nozzles. See that? See the lines? That's a gimbal mount right there, and if anybody's wondering. That's the AON-R vacuum engine. Or AON V is what they call it, that's right. See, it has the recirculator manifold. Nice flex joints. Those are dudes sitting at a desk. That's a thrust vector actuator. Valve. Hardware in the loop testing. That looked like a server rack, if I had to guess. Now, these next pictures are what I really want to see. There's some pretty cool stuff from what I just saw in there. He's ratcheting. Yep. I wonder what tool that dude was using. Hold on, let me see. What are you ratcheting? What? Nah, not a tang. That's a shame. He's got a crow's foot, though, on a breaker bar. Crow's foot on a breaker bar and a 3/8 torque wrench. It's not tang. That's a tang shame. Snap on. Yeah, that would be my guess. Yeah, I worked with that guy during my internship. Oh, yeah? Oh, yeah? Nice dude? Yeah, I own one of those snap-on torque wrenches. That's great. It's not tangs. It's not a tang, son. No. Yeah, good testing there. I wonder why they're blurring out the, why they're blurring all that stuff out. Interesting, but they didn't blur it out there. All right, whatever. This is what I want to see. So that's the old A2 test stand at Stennis. Once upon a time, this was used during the Apollo program. I do believe it was for testing Saturn V second stages. And then they retooled it for testing shuttle engines. Really nice, very smart, knows its butterfly valves. Oh, yeah? So NASA put the A2 test stand up for lease, and they used the A1 test stand for SLS testing. Look, they put a launch mount in there. So that tells me that they're doing first stage testing with this thing. They're going to do an integrated first stage test, which means they're putting the first stage on top of this thing. Which, okay. I'm here for it. I'm here for that. That's pretty sick, actually. Yeah, they're going to just test the whole integrated first stage on that stand, which is pretty cool. This is out at LC-16. This is at the cave. The other one was at Stennis in Mississippi. Let me go back. I want to see that even more. I want to see how old this picture is. Yeah, that picture's still a ways away. They've started moving that water tower up. The water tower isn't finished. They're going to lift it, and then they're going to put supports under it, lift it again, put supports under it, lift it again, put supports under it. But very interesting here to look at. That horizontal integration facility is the size of Terran R, and this horizontal integration facility, that little guy right there, is Terran 1. Terran 1's old pad is right there. Yep. Okay, they're gonna have lightning towers. 30 meters tall. Okay. See that little guy? I wasn't worried about that little guy. Now this. The received the launch mount and transporter erector upper strong back assembly. Look at this. All right. Huh. Interesting. I wonder how those two pieces fit together. Why blur the barge registration? Did they? Yeah, okay. As freaking if, dude. The freaking tug's name is right there. Like, who are you trying to fool? Erected steel framing for engineering support building. Interesting. I don't know where that is. I don't know where that building is. If you guys are wondering where this factory is, that's their factory in Long Beach. This is the old C-17 production line. In fact, yeah, you can see that this area right here is wide enough for a C-17 to roll out, and then the hangar door in the back right there is wide enough for it. I would argue that we should probably not stop making more C-17s, but, you know. Yeah, no. It also looks like there's a landing pad over there. See that? I didn't know Terranar has 13 engines and produce 3.5 million pounds of thrust. It's way bigger than I thought. It's bigger than a Falcon 9. Yeah. Terranar is supposed to be able to do with reuse, Trey, with the landable first stage, what Falcon 9 can do in expendable. That was the idea. Or a go-kart track. I mean, there's no reason you can't do both of those things, dude. Just saying. Yeah, you can see Terran 1's old launch mount is right there. This is a little bit bigger. Still sad that 747s aren't being produced anymore. Yeah, because why keep making the thing that's awesome? You know, we have to make stuff that sucks. That seems to be the job now. Like, oh no. Why keep making this awesome thing? Let's keep making things that suck. All right. Anyways, speaking of things that don't suck, Firefly has a recap video of the Stairway to 7 mission, which went off last week. It has music on it, so I can't really listen to it. But, yeah, the Stairway to 7 was Firefly's Alpha Block 1 last flight. In anticipation of Firefly Alpha Block 2. This carried a lot of Block 2 components that were being tested. So this is actually a pretty high profile flight for Firefly, and it seems to have gone off without a hitch. You can unmute the audio at the 40-second mark. Oh, all right. I'm pretty happy for Firefly. They haven't had the best success with Alpha, but this mission seemed to... Mission seemed to work real well. Nice. Hats off to everybody over there. That's really good. I was getting a little worried with all the scrubs, man. I was like, something's got to be wrong with this thing if it's going to scrub so many dang times. But teams there showed some pretty good grit, and they actually got the thing up into space. So that's huge for them. Real big deal. Good stuff. Good stuff to see. Okay. Now, the next thing I got for you is coming from NordSpace. NordSpace is a Canadian commercial satellite launcher here. Let's see what they have to say. It looks like it's a lot. All right, so today marks the most significant milestone in NordSpace's history. We have been awarded an $8.3 million Canadian in Phase 1 grant funding as selected as a winner of Canada's Department of National Defence Launch North Ideas Challenge towards the development of our Tundra orbital launch vehicle. Launch the North represents Canada's most significant investment in sovereign space launch. As part of the government's $182.6 million investment in sovereign space launch, Dungeons and Dragons and the Canadian Air Force aim to secure Canada's strategic autonomy in space, reduce dependence on foreign launch providers, and position Canada as a global leader in the commercial and defense-oriented space launch. Canada's moment has arrived. What distinguishes NordSpace is the depth of its vertical integration. We design and manufacture our own engines and vehicles, develop and operate our own spaceport, build and fly our own satellites, and invest in the broader Canadian space ecosystems. This end-to-end architecture stands unique in Canada, inspired by industry leaders such as SpaceX and Rocket Lab, and constitutes the foundational infrastructure upon which a durable, truly sovereign Canadian space industry can be built. Department of National Defense. Guys, for the love of Christ, I know what it means, and I know it doesn't mean Dungeons and Dragons. Holy fook. Something wrong. That's what was called a joke. Okay? It was a joke. It was a joke. Holy fook. Bing dang ow. We know you know. No, I'm not sure that you do. All right? No. I'm not sure that you do, actually. I'm actually wondering at this point. At the center of our architecture is Tundra, powered by our in-house design and manufactured 3D printed Hadfield engines, and capable of delivering 500 kilos to low Earth orbit and 350 kilograms to sun synchronous. In its Tundra Plus configuration, this grows to 1,100 kilograms to low Earth orbit and 850 to sun synchronous. With a direct scaling path to our Titan medium lift vehicle, targeting 5,000 kilograms to LEO. A proven modular 3D printed engine architecture reduces development time and risk while ensuring Canada's sovereign launch capability grows in step with national defense, commercial, and allied demand over the coming decade. You see above, Drunar, your above message was retracted. Our Atlantic Spaceport Complex, ASX, in Newfoundland and Labrador is the only purpose-built commercial orbital launch facility in Canada and one of the most strategically advanced launch sites in the Western Hemisphere. Firefly CEO looks like Bruce Eng.
Discovery,
Eng
go and
from
throttle up.
Benedict Wong from The Martian. Yeah, okay. Yeah, I got you. The ASX supports launch inclinations of 44 to 105 degrees out over the Atlantic Ocean, the widest range available from any Canadian site. It also offers the largest safety distances of any spaceport in Canada and the highest approved launch cadence, lending to our medium lift future. The ASX received its landmark environmental approval from the government of Newfoundland and Labrador and is already under rapid construction with its first launch planned this spring of our Tiger rocket. This award will ultimately lead to the creation of 134 jobs by 2028, growing to 650 by 2032, with 1,600 indirect and induced jobs across Canada's industrial base as we continue to scale to medium lift. We rely on a wide ecosystem of our Canadian partners, including Magellan Aero and Kongsberg Geospatial, Secor, and Indigenous-led suppliers across the country. No, go away. It looks like the Mahia Peninsula launch site in New Zealand, only colder. Huh. Okay. That... Uh, okay.
Discovery, go at throttle up.
Look, I'm seeing things. I'm seeing things that I'm like, what are you doing? Hey, it's a 40-month resub. A subscription is never late, nor is it early. It arrives precisely when it means to. Yeah, I'm not... Okay, look. It's not that any of these plans are bad, okay? It's not that any of these plans are bad. Having an indigenous launch capability for your country, that's all good. Totally understand that. Wanting to scale from your Taiga to your Tundra to your Titan. Why name it that? I don't know. Rockets, that's all fine and dandy. $8.3 million is not enough to do any of that. First of all, now that's Series A funding, so that means, or whatever the Canadian equivalent of a government investment in a program is. These look, I'm not one to doubt. I'm cheering everybody on. These are very ambitious goals for a company who went to put that Taiga rocket out on the pad and it literally lit itself on fire. I'm not trying to be mean, but this thing, they put this thing out on the pad and they wanted to do a launch test, and The rocket puked its guts out all over the pad, lit the pad on fire, and then NordSpace said it was the propellant's fault. So that, that happened. And we haven't heard anything from them until this. Now, once again, rocket science is difficult. I understand that and I get it. But, they announced all these goals for 3 different types of rockets, total all up vertical integration, right? And their pad is a concrete slab with some metal and it looks like some scuba tanks. Now, once again, that's not to be mean. I'm not saying that to be mean. This stuff is difficult, okay? Could I do any better? Probably not. Could I do any better with $8 million? Probably not. Yeah, probably not. I'm going to go ahead and say that. Could I do it better? No, absolutely not. But here's the thing. Look, man. They want fully reusable or partially reusable rockets in the coming decade. And right now, in the year of Jeb 2026, you got a concrete slab in Newfoundland with a rocket that lit itself on fire, and that's about it. I'm not 100% sure where you're going with this. There's it says right there, 182 million invested in accelerating sovereign space over the next 3 years. 182 million is not nearly enough to build 3 launch vehicles over the next 10. That's not even close. And I understand they're preparing to scale up, but look, it's very easy in the spaceflight industry for your eyes to be bigger than your stomach. It is very, very, very easy. I'm going to do all this great stuff. I'm going to do this, and you're not going to get anywhere. It's very easy. I think step 1 is partially reusable rockets. You don't have to be a good cook to know the food you're served sucks. Yeah, look, I wish them the best. I hope they do well. But once again, dudes, what happened with this thing during the last test that they did, when they intended to launch and all they did was have the rocket puke propellants all over the pad and then light the pad on fire, and then proceed to blame the quality of the liquid oxygen for, comparatively to their test stand. That does not give me high hopes. Yeah, no, Trey, no, yeah. That does not give me pretty high hopes here. But with that being said, it's clearly enough to attract some investment. You should start a Kickstarter and make a rocket company. Well, like Cpon's sister, where my mind is going with this is that look, these guys don't even have a functioning demonstrator, and they got investment. Like, clearly you can talk your way into getting seed money. So, like, I'm good at talking, like, maybe we should do maybe we should do that, Hey, Star Citizen raised more money than this rocket company? Oh, geez, Red. Star Citizen. Oh, you're right. You're right. Oh, no. But yeah, well, you're not wrong. Yeah. I don't know. Like, all this sounds really fine and dandy. This sounds like a great plan, but, I'll admit, they haven't gotten off to the greatest start. And this isn't like, they went to launch the rocket, right? And they went to launch the rocket and it failed on ascent, or it failed at max Q, or it blew up or something. Like, this thing, they went to fuel it on the pad. One of the valves got sticky, puked fuel all over the place. The fuel lit on fire, and then they blamed the quality of the locks, which is Look, you cannot blame. Okay, playing the blame game in commercial spaceflight is not a good idea. That is not a good way to do things. You could sit there, right? You could sit there and say, well, it's the LOX. It's not their fault. The quality of their propellants weren't as tested. Well, whose fault is that? Whose fault is that for putting that in the vehicle? Whose fault is that? Seriously, whose fault is it? You wouldn't see Rocket Lab or Relativity or anyone else saying stuff like this. You know, I'm also amazed in their business statement they dropped SpaceX and Rocket Lab potential competition as their inspiration, which is I don't know who your like legal counsel is, but you probably shouldn't have done that. Like, that's a little weird. But yeah, that's a little peculiar. Yeah, little peculiar. But hey, once again, like, I'm not trying to be mean. It's phase 1 funding. It's phase 1 grant funding from the Canadians Dungeons and Dragons. All right, the Department of National Defense for the Canadians. That's cool. And more companies, the more companies, the better. With that being said, yeah, you know, these ideas are all fine and dandy. Please do them. Do them. Because the last time you tried to do it, it didn't work. Like, I'll be honest with you. You're talking a lot of game. You're talking a lot of game, but you don't have any game to back it up yet. Give it some time. Like, but these are awfully specific scaling strategies for not having any rockets. Why are you saying you're inspired by SpaceX Strange? Name dropping a company like that in a press statement is a little weird. That's just, I don't know if it's like a taboo thing to do in the industry, Fox, but nobody else does that. Did Flame Trench already cover the lunar trail? No, we didn't. We never covered that for Flame Trench. Yeah, do hardware in the loop testing to make sure your solar panels point actually at the sun, so you don't lose emission. Is probably the moral of that story. But yeah, once again, I'm not trying to be a jerk. I'm not trying to crap on them. You can't make excuses like that. All right, especially with this grandiose of a business strategy. This is a lot. That's a lot of work, man. You want to scale to 5,000 kilos to Leo, okay? 5-ton Leo, that is approaching medium duty lift. And so far, the Tiger rocket, a subscale demonstrator, has never launched. And it last time it launched, they made a bunch of excuses about the propellant, which is very weird. Urist, in your opinion, NordSpace has trust fund kids startup energy. Yeah. That's very much what it feels like. These are super ambitious goals. And honestly, like, if it was me, dudes, if it was me, I would not even say stuff like this. No. I would focus on the task at hand. Now, in your proposals for grant funding, right? For grant funding in your proposals, that's what you'd ultimately say. But I wouldn't be telling people this. That sets up really poor expectations for you to fail. Yeah, I guess, caveman, right? Like, you know, in this industry, you got to focus on one thing. Focus on one thing. You have 3 rockets in the pipeline, and you can't even make one get off the pad right now. Like, hello, I'm back. Anything important I missed? Lava, what we're discussing right now is that NordSpace got an $8.3 million Phase 1 grant funding from Canada's Dungeons and Dragons, Department of National Defense. As part of the government's $182.6 million investment in the Sovereign Strategy space launch, it's part of the government's $182.6 investment. I'd be curious to see where that $182 million went, if it went all to NordSpace or went to anywhere else, because they cited that number in their promo video, which is... What did they say in their promo video? Hold on, let me look. Why would you cite this when you didn't get all of the money? Let me see. Canadian-owned spaceport. Demand for timely and resilient launch options are at historic highs worldwide, and sovereign access to space has become a critical capability underpinning national security, economic competitiveness, and reliable access to essential space-based services. The investment is a 10-year, $200 million agreement to lease a dedicated space launch pad that will serve as a central foundation for a multi-user spaceport near Canso, Nova Scotia. Operated by Maritime Launch Services, this spaceport will support operational needs of the Department of National Defense, Canadian Armed Forces, and the wider government of Canada, while also offering ad hoc access to allies and partners. Also announced was the selection of innovations for the first round of the Innovation for Defense, Excellence, and Security Ideas program. The Launch the North contest. This contest is providing $105 million in multi-year grants to support the development and demonstration of breakthrough technologies to advance Canada's sovereign space launch capabilities. The goal of this challenge is to enable the launch of Canadian payloads from Canadian soil. Oh yeah, bud, that sounds great. Achieving an initial light lift operation capability by 2028. By 2028? Okay. For the first round of this contest, the following 3 highly ranked applicants have been each conditionally approved for $8.3 million in funding: NordSpace, CRC, and Reaction Dynamics. Canadians, I'm sorry to say this, but that's really not enough money to do this kind of stuff. Is my finger on the pulse here? That's even though it's a 10-year multi agreement, $8.3 million bucks. That's, am I being a dick? Like, I'm not trying to be a jerk. I wish you guys all the best. Like, genuinely, I do. That's not enough money to do any of that. That's not enough money to do any of those things that you said that they wanted to do. We'll show you. We'll fuel our stuff with maple syrup and moose farts, bud. Oh yeah, do it. You should. That'd be great. Yeah. 8.3 million is not going to get you very far in spaceflight. Like, you're not going to walk a very long distance with that amount of money. Even on a, if it's on a yearly basis and companies like NordSpace are getting 8.3 million a year, then maybe, yeah, that's enough. But that's 8.3 million a year for like the next 10 years, that might get you there. But they want operational light lift capability in 2 years. That's not, like, dude, look, unless Canada has some super rocket that runs off maple syrup that they can scale extremely quickly, that's very unlikely. It allows them to brag about it. That's the whole point. Come on, we only have like 10% of the US GDP. Yeah, I know, Urist. I understand that, and that's all fine and dandy, but these are hollow words if you don't have the capital to back it up. I mean, you could use glucose as fuel. You could use maple syrup. That's possible. There isn't a market to sustain it, and Canada isn't willing to spend the money to subsidize it to the point where it could actually work. That's kind of what I'm worried about here. Like,
Discovery, go at throttle.
You're under the false pretense that what Canadians do is understandable. Oof. Like, here's the thing, dude. It's like even that NordSpace thing, like, you know, you're announcing all this stuff. This is all great. This is a great strategy. Look, man. Look. Say they are getting $8.3 million as the contract suggests. They're getting $8.3 million a year in Canadian subsidies over the next 10 years. That's it. What is that? 8.3 million. That means $83 million till 2036. 80 million Canadian till 2036. Look, man, that's enough to maybe develop a small sat launcher. Maybe if you were really tight on your vertical integration. Yeah, I know it, but I don't need to see your last. I saw what you said. It really is, isn't it? No, you shaved. Hey, it's getting warm out, man. I figured the winter beard is good. Like, we don't need that. But yeah, it's apparently going to get cold again. So screw me, right? That's just pushing about $60 million American. Like, super, like, I'm not going to sit here and pretend like that's enough to get something done. You could build a small sat launcher for that. If you were tight on your vertical integration and tight on your budget, sure, absolutely. Using off-the-shelf components. But they're not. That's not what this is. They want to grow the industry in Canada. You are not using off-the-shelf components. You are not borrowing components from the United States or anything. They want indigenous launch capability. They want a completely vertically integrated homogeneous supply chain. That's going to be way more than $8.3 million or $186 million invested a year. I'm sorry. It's like you're not getting around this. This is not, and that's not to say that Canadians couldn't do it. I know you guys are smart. You guys aren't stupid. Like, I get it. If you were given the money that was required to actually get this done, I'm sure you could get it done. Because we know good and well that throwing money at a spaceflight problem is not that just because you have a lot of money doesn't mean you can get it done. I know that you guys have the Canadians have the grit to get this done if they really wanted to. I know they do. But also this is a lot of, dare I say, like farcical information here comparatively for the money invested. Like, this is a huge business strategy that's going to cost millions of dollars. More millions than the investment money that you're getting. You know, like, it's a good start. And don't get me wrong, guys, like, it's better than nothing. But look, man, all right, let me put it to you like this. And I'm only saying this, like I said, I'm not trying to be a hater. I'm really not. I want you guys to succeed. More companies, better. That's great. That would be fantastic. Right? That means I could see more launches from my house potentially. That's fantastic. Please do that. Look, if I am running a company and we're getting an investment to the tune of $8.3 million a year, I would be very, very tight with my business strategy. I'd be very tight with my testing. And what do I mean by that? I would not hire a lot of people. This would be a very small team of people. Very small team with very, dare I say, like, not rudimentary goals, but I'd be like, yo, let's move 10 kilos to space. That would be a good start. 10 kilograms to orbit. 8.3 million, that's about right. You should be able to do that. And then you can scale that technology from there. But we don't see that. We see 3 rockets here in development. 3 rockets over the next 10 years for $60 million US. And that's just going off grant investment. That that is not a very sound business strategy, dudes. I'm not gonna lie to you. That is not. Your scope is way, way too big for having just that right now. That's way too big of a scope. You got to dial it back. And maybe they know that. Maybe they know that. Maybe they're just saying this to drum up investment. There's a lot of promo and there's a lot of buzzwords in the rocket industry, in the commercial rocket industry nowadays. Like rapid reuse and rapidly deployable and mega constellation. Like there's a lot of buzzwords to get finance bros' attentions in the commercial space industry nowadays. So, you have to drum up some stuff, but yeah, I don't know, man. I think part of their strategy is getting other countries to invest, and the fact that they've been pushing the NATO angle and the non-ITAR. So, Geeson, who's going to invest in this? Who's going to invest in this? The Europeans? That who is this business? Who is this for? I understand establishing sovereign launch capability, but if you're trying to make an investment pitch to people that aren't the United States when you're in Canada, guys, not even Elon and SpaceX had this goal when before Falcon 1 flew. It was just make Falcon 1, get that thing to work. And then maybe we'll work on after Falcon 1 and the commercial crew program or the commercial orbital transport systems contract came around, right? That's when you started seeing Falcon 5, Falcon 5 Air, Falcon 9, right? That's when you started seeing that kind of stuff roll around. I mean, I don't know, dude. I want NordSpace to succeed, but this seems it's easy to talk a big game in spaceflight. It's very, very, very easy, especially with this stuff right here. Yeah, guys, I understand the context for wanting to establish your own sovereign launch capability. I don't think we need to get into the weeds at all with the reason why Canada wants their own launch capability. All right, that's pretty self-evident, given the circumstances. However, you're going to need to ramp up investment if you really want this. Interesting. All right. I mean, I wish NordSpace the best, but I haven't seen anything that's gonna show me right off the bat they're gonna do it. They have a transporter erector that's operated by a crank pulley. Not saying that's bad. I'm just saying if you want to move a 5-ton, if you want eventually 5-ton to, even the next vehicle, the vehicle that's supposed to be better than this, the Tundra rocket is, that's not going to roll that way. That's the thing. They probably don't really want it, but they want to be seen wanting it because it looks good and gets them reelected. Yeah. All right. Next bit of news. Anyway, yeah, I wish NordSpace the best. I really do. I mean, they put a lot of food on their plate. Let's see if they can do it. Nord is getting elected. Nord is the Edison of rocketry. Yeah, I don't know. I don't know. Like I said, I'm not trying to be a hater. I'm not trying to be a hater. If anything, I'm trying to give criticism so they succeed. I think those goals are extremely lofty. You just dial it back. Dial it back. Focus on one rocket. Focusing on 3, or even thinking about launching 3 when you haven't launched once with your demonstrator rocket is that your eyes are bigger than your stomach. Stop. Dial it back. Dial it back. You really need to just dial it back. And I'm not saying this because I'm a hater or anything. I'm not saying this because I'm American. I don't care. You guys get your launch capability. I want you to have that. And then I can see, like I said, then I can see launches from my house. It's just that's a lot of scope. That's a lot of scope and not a lot of funding. So if you have a large scope and not a lot of funding, that means it's going to take time. And remember, that stupid bill says they want to establish light lift capability by 2028. The math ain't mathing. Would you care to comment on 3D printing for making engines? I don't have any particular issue with it, Blark. I wouldn't be making engines that way if I was with my rocket company. 3D printing has a good application for certain types of engines, but for like lift engines on a first stage, I'd prefer spin forming if you really want my honest opinion. I think spin forming is much better. Spin forming with a liner installed after, I think would be a better idea, but what do I know?
Oh, this is space. I'm in space.
Americans criticizing spaceflight pork with zero irony. Because I never criticized SLS, Jurist? If you're gonna make a joke, at least make it good, man. Here, how about this for criticism? Fucking launch something. Oh, wait, you won't. Boom. Let's go back to the rest of the space news. Processing continues at Cape Canaveral, where the Atlas V rocket team is preparing for its 5th Amazon LEO mission. The rocket has completed initial buildup and will undergo system checkout before the payload is attached. Liftoff is targeted... I'm just kidding, by the way. Jesus Christ, just in case anybody took that seriously. Liftoff is targeted for March 30th at 3:31 a.m. All right, we got another Atlas V with Amazon LEO. Let's see. When is that? So that's targeting March 30th at 3:30 in the morning. Oh, that's great. Monday. All right, Monday morning. I'll try to be around for that. We'll see. Because there's only so many Atlas V launches left. Oh boy, 3 a.m. Yeah, let's see. Thinking how many Atlas V's do we realistically have left? Like 12 or 13, something like that. There's not a lot. Yep, there's a other picture of the LVOS, or launch vehicle on stand. There it is. So that's the Atlas V CCB, the Common Core Booster. It will eventually have 5 SRBs attached to it. Interesting. Yeah, there's only so many of these left. Yeah, see, actually, in this picture, these pictures were taken before. So that's LVOS, a launch vehicle on stand. It's called LVOS for short. And then in the next picture, they're installing the Centaur. The Centaur in the Centaur in the interstage with the CFLR, forward load reactor. The next thing that happens is on top of this is the payload fairing. In this picture, the CCB already has the solid rocket boosters attached. There's 3 on one side and 2 on the other. Okay. We got more stuff coming from Blue here in this next bit of news. Work alongside JPL and Caltech, we've developed a near-Earth objects hunter mission concept for planetary defense using Blue Ring. Neo Hunter tests multiplied asteroid deflection techniques, including ion beam deflection and robust direct kinetic impact, helping protect Earth from potential threats. This is another example of how commercial platforms like Blue Ring can conduct low-cost, high-priority science, exploration, and planetary defense. Blue Ring, guys, from that's actually super cool. Asteroid redirect in the not like the mission, but it's a redirect for planetary defense. This shows that Blue is cooking up Blue Ring, and what Blue Ring is kind of an a la carte long duration loiter satellite. Like it's something that's designed to basically like a modular space satellite. You could just attach random things to it, like a redirector beam, right? The idea is that it's already a satellite chassis, and you just attach what you want and go from there. It also offers there are also defense applications, which are, if I had to guess, observation, like maybe potential in-space satellite observation of other objects or whatnot. But yeah, Blue Ring is like a long-duration loiter satellite, which is actually pretty cool. It's a modular sat bus. Not modular in the fact that you could pull stuff off on and off of it. Like when it's on orbit, it's modular, like you can make a lot of them and you could just kind of a la carte swap components. Think of it like if you have a buffet, right? You have a buffet, you grab the plate. All the plates are the same, but you could put different food on them. It still does the same thing. It's not like you have different plates. Anyway, that's cool. They're working on a Neo Hunter mission. So we don't have to send up Bruce Willis up there if there's an asteroid coming at us. Rocket Lab is kind of doing that with sat buses. Yes, they are offering a la carte sat bus services. That seems to be where the industry is trending, Shaw. I bring my own plate. Buffet plates are too small. Do you really bring your own plate to a buffet, Tessa? Do you really do that? Or were you making a joke? Because that's borderline, like, psychopath behavior. You like that, Sad? Yeah. Joke, mostly. Right. Take some Ziploc so you could take the leftovers home. That's that. Okay. All right. Okay. That's just y'all are sick. Y'all are sick. Y'all are sick. Not a bad idea. You'll do that next time. I'm just gonna go to the next bit of space news, huh? ESAR Aerospace. Demand for launches is surging. Okay. ESAR Aerospace is teaming up with Astroscale UK to launch the ELSA... Oh, God. That's almost my name. To launch the ELSA-M mission. Our first active debris removal flight. Paving the way for a cleaner, more sustainable space and boosting Europe's satellite capabilities. Read more. Thank you very little. I will. We use cookies, so get out of here. All right. Let's see. München, March 16th, 2026. Spaceflight company ESA Aerospace has signed a launch services agreement with Astroscale Limited, the UK subsidiary of Astroscale Holdings Incorporated, to launch the ELSA-M in-orbit demonstration IOD mission. No? Hey, it was pretty good. That was pretty good. This mission represents a major milestone for Astroscale's pioneering end-of-life removal services and adds to ESAR Aerospace's rapidly expanding launch manifest, underscoring the strong global demand for flexible launch from Europe and the trust and the trust customers worldwide have in companies' launch capabilities. Okay. We won't read too much into that. Okay, so as of note, guys, the reason why I stopped on this, trust in the customer. Okay, so the context of this statement is that they believe they have the launch capability to do things. The reality of the situation is that ESAR went to launch their Spectrum rocket once. It went up about 300 feet, flipped over, came back down, and crashed next to the launch site. So, that's very interesting that they'd say that way. But, the ELSA IOD launch will mark a critical step towards commercial in-orbit servicing as ESAR Aerospace's first end-of-life mission. It demonstrates the company's ability to target specific orbits required for a rendezvous mission, meeting the unique requirements of customers worldwide. Now, to credit ESAR, and I'm not just saying this because I work for NSF, to credit ESAR, they were the first ones, the first part of a new wave of like European commercial space to actually get a vehicle to the pad, test it, and launch it. To their credit. To their credit. And I'm not saying that, like I said, I'm not saying that just because NSF does work with them. NSF does the production services for their launch. And they do, NSF does a good job. They are well ahead of our Rocket Factory Augsburg. They're well ahead of Maya Space. I would say they're probably racing PLD, which PLD is a Spanish company. But yeah, it's just interesting to manage that they're, they say this, I thought it'd be interesting to mention that as a matter of factly. Like, it's not a slight against ESAR. They actually had the balls to put a vehicle on the pad and send it. And it made, dude, getting a vehicle off the pad for your first try, cold turkey, like no launch experience at all with any vehicle, and having it get even 30 seconds into flight is fantastic. That is a huge capability. But it is a launch capability, but it's very, like I said, the context of this statement is that the company that Astroscale thinks they can do it, and I'm not going to sit here and pretend like ESAR doesn't know what they're doing. They're pretty damn good. They wrote that, from what I understand, from what I've heard through the grapevine, they run a pretty damn tight ship over there, which is what you need to do when you're in this industry, unlike, past mentions of other companies in this space news. Would not a shuttle-type ship and crew... What is that, Shogun? Would not a shuttle-type ship and crew with butterfly nets work better as a space junk collection system? I don't know. Make it. Find out. Space junk collection is really I would call it a developing market, meaning that there's no really established standardized way of being able to go and get space debris back. It's not like it's not like it's reached a convergent design point, let's say like the commercial airline industry, where every plane nowadays is just looks exactly the same. It's just a different size. Like, it's not exactly like that. The context is the marketing team wrote that. Yep. Yeah. Astronaut guy, that's a good point. It's a good thing to be able to launch for your competitors so you can refine and get more payloads. Yeah, that's what I mean. They had the stones to go and send it. It didn't work, but they had the stones to do it. This mission will be launched aboard ESAR Aerospace's Spectrum launch vehicle from the company's dedicated launch site at Ndoya Space. The Spectrum launcher is designed, built, and operated entirely in-house, utilizing a high degree of automation. This approach enables the company to scale manufacturing and meet surging global demand. Okay. Like I said, Astroscale must have confidence in their launch capabilities, just like the statement says. If they're willing to put their payload on it with no successful missions, I would say that's pretty high confidence. So the statement isn't exactly wrong. So hats off to ESAR for getting more investment. That's great. And well, not more investment, more contract services. That's fantastic. All right. Let's see. What else do we got? Oh, yes. This space news article from last week. Check this out. Starlab Space fully books commercial payload space on planned space station. Check this out. The Starlab commercial space station has booked its commercial payload space as the joint venture The Starlab commercial space station has fully booked its commercial payload space as the joint venture developing it waits for the next phase of the NASA program. This is coming from Space News. This is by Jeff Faust. In a March 10th earnings call, Dylan Taylor, chief executive of Voyager Technologies, whose company is leading the development of the station, said Starlab was seeing strong commercial demand. I'm excited to share with you that Starlab's commercial payload capacity is fully reserved, providing early visibility into the future utilization and revenue potential of the station. I think it's a fantastic outcome given the fact that we won't be on orbit for another 36 months. He did not disclose details about how much payload space was reserved or by whom. However, the announcement coincided with a release by Starlab Space saying that Yuri, a German space biotech company, had reserved an unspecified amount of payload space on Starlab for the station's first full year of commercial space operations. Yuri has secured a dedicated capacity for the entire first year of Starlab's operations. It's not a single campaign or a short duration mission, but more sustained year-round access. Huh. Brad Henderson, Chief Commercial Officer of Starlab Space, said in the statement, Starlab was designed to support exactly this kind of persistent commercial activity, moving the market beyond episodic access and towards reliable, scalable infrastructure in space. Starlab did not disclose the terms of the Yuri agreement in other recent announcement of companies reserving space on the space station. In the earnings call, Philippe de Souza, Chief Financial Officer of Voyager, said the company has booked $6 million in backlog related to Starlab, which is quarters ahead of where I would expected. Voyager is the largest partner in the Starlab Space joint venture, which includes Airbus, Mitsubishi, MDA Space, and other companies. Voyager has a 61.9% stake in the joint venture as of the end of 2025, according to Voyager's Form 10-K filing with the Securities and Exchange Commission on March 10th. Work on Starlab has been supported by a NASA Space Act agreement through the first phase of the agency's Commercial Low Earth Orbit Destinations, or CLD, program. Voyager said NASA has disbursed $183 million to date under that agreement, which has a total value of $218. Interesting. Now, this is an excerpt from this. The company, so commitments and contingencies, non-cancelable service contract commitments. Company has a commitment for launch services for the Starlab program. As of December 31st, 2025, the company had a commitment for one launch at a future estimated launch date for $90 million. The terms arranged allow the company to terminate the agreement for convenience for 25% of the contract value, less what has been paid inception to date. The company has commitments for various services to assist in payload and launch analysis for the Starlab program and throughout the business units for various contracts. So this post that Creeper, I have a question. This post that you linked, one Starship launch equals 90 million. So this is by Robin. Robin posted this. Where are you getting that any of this is Starship? Where's that link all coming together? I'm trying to figure this out. There's no mention of Starship at all. Starlab is set to launch on Starship. Can you give me that in... Is there like a direct link saying that they're going to do that? Let you find it? All right, cool. Well, speaking of commercial low Earth orbit destinations, take a look here. The FAA News has made a favorable payload determination. This is coming from VAST. The FAA has made a favorable payload determination for Haven 1 following interagency reviews with NASA, the State Department, the Commercial Department, and national security stakeholders. This marks another step forward in launching Haven 1, expected to be the world's first commercial space station when it is ready to launch in Q1 2027. Cool. This is off of next space flight. Okay. That was me, because Windows, even though I have Windows noises muted, it still wants to play noises because I have it muted in the mixer and it still's playing it. So that's good. Sorry about that. That was on my end. Wikipedia lists Starship based on this article. Well, that Windows noise was me searching for Starship in that article that you linked, and I see nothing about SpaceX nor Starship. Yeah, see, am I missing something here? Really wish it wouldn't play that noise. I just remuted it. That was a Control F. It can't find what it's looking for. Also on their website. We selected SpaceX's Starship to launch Starlab into orbit on a single flight prior to ISS decommissioning. Oh, well, that's good enough for me. That's off their website. Cool. That's all I wanted to see. I just didn't really see any official confirmation of it anywhere. But yeah, very interesting. Orbits, what do you got? I am going to Florida from the 30th to the 6th. I wouldn't bet on it, but gosh, it'd be cool if your first in-person rocket launch was Artemis 2. I'd say there's a strong likelihood of that happening. Orbits, if you are going to try and see that launch, get there early. That's all I'm going to say. Get there early. Artemis 2 will be by far and away the busiest the Space Coast has ever been. Or has been probably since the last shuttle mission. Yeah, okay. There's plenty of references. I was just wondering, because like I didn't read any references about it in that article or anything. But yeah, still cool. Now, fellas, I'm just going to pop into what we were doing I was about to say this morning, but it was more this afternoon. So here's a live shot of Starship, or Super Heavy, over on Starbase Live from my buddies over at NSF. This morning, dudes, so this is a live shot right now, but there was something that happened, and well, here, let me get a link to it. It looked like a static fire, but it might not be a static fire, but it's hard to say whether it's a static fire, so let me... Here, check this out. This was from the official NSF cast. I wasn't able to get in there. They had a full house before I was able to sign in over there. So it was Ryan, Sawyer, and Max today. Let's see. Now, this was earlier in the day. I may have super chatted, help, help, help. Alex was there too. Yep. Now, guys, we theorized when I was watching it, when it was live, that it was either a fire and an abort, like they tried to fire the engines and the thing stopped right away, or it was a quick pulse of the engines. It's one or the other. The more I watch this, the more I'm kind of coming down in favor that it may have been an abort. But I'm not going to rule out that it could have been a quick pulse of the engines either. The big reason why I'm not going to be like, no, it was this, or no, it was this, is because we don't know. Nobody knows. It's really hard to say. And now I'm not just saying that to be intentionally vague. This is a new pad, new rocket, new engines. Yeah, it carries the Starship Super Heavy name, but this is a complete redesign comparatively to what we've seen in the past. We have a 1 in 2 chance that it was one or the other. Yeah, exactly, right? I'm not going to say one way or the other till I see more conclusive evidence or something from SpaceX about this. But I can very much see how it looks like a fire and an abort immediately. But I can also see how it looks like it's pulsing the engines as well. I do not think it's a spin prime. No, we ruled that out pretty conclusively. There's 10 engines on board. Aqualex, yeah. Firing and blowing up are still two different things. Yeah, no doubt. Ryan went the other way. He thought abort at first, but by the time the road opened, he was thinking it was as planned. Yeah, I don't know. My first reaction was that it was a single pulse of the engine. Because honestly, looking at this, it looks fine. This looks right. You have... Yeah, this looks okay. And my big tell was that they didn't go into an emergency depressurization procedure, because that would be the first thing to do to safe the vehicle, bring the tanks down from flight pressure. But after ignition, it takes 5 seconds, and exactly 5 seconds, like it's pretty much almost exact for the depressurization vents to come on. Now, that could see right there. That tells me that this was a quick pulse of the engines, but I don't know. I could also very much see an abort here as well. I think they burped a single engine. I disagree. I think it was multiple. There's no reason for burping a single engine here, goalie. It would most likely be multiple because they've burped a single engine many times at McGregor. That doesn't make any sense. But dang, dude, did that kick up a lot of dust. Well, steam. It looks like it dissipates too fast to be exhaust. Yeah, Mutter, it's all... Like, once again, this is all unproven. We don't know. It's hard to say. Like, it's hard to say conclusively what this is, because this is, like I said, new pad, new everything. We're gonna need more tests. We're gonna need more testing so we can kind of sequence these events and figure out what's what. It's definitely... It's like watching Starhopper for the first time, like back in the day. Sarah, I wouldn't rule that out either, yeah. Engines for pad validation, mostly because it's what they mentioned was up next. Yeah, that's a good point. You know, considering that, I would say this is more of a routine test. They burp the engines on purpose. I would say that that's right. Google Lab Padres cam for the thing on the chine. There's some tape that came loose, blocks, but yeah, it seems alright. I have to read up on acoustic igniters, but do you think they could have a higher chance of a hard start? Do they still use the pad to light some of the engines? It depends on which engines, Mutter. Yes, the pads are... the outer ring of 20 engines is actuated from a pneumatic system from the second booster disconnect. Non-aerospace guy here, why burp the engines at all? You gotta start somewhere. Totally new design, Joho. Once again, dude, think about, like, if you're making an airplane, right? Say you're an airplane designer, right? This is non-technical, right? You're an airplane designer. You design a little propeller plane, like a Cessna or something, right? Good, you made that work. And now they're like, no. Your boss at your plane engineering company is like, no. We need you to build a 737 style plane next. You're going from building a small single engine, piston air-cooled propeller plane to a twin jet engine, and right, it is totally different. That's a totally different airplane. Like, you don't need to know much about planes to know a 737 and a Cessna aren't the same thing. They're not even close. The one thing that they have in common is that they have wheels and they fly through the air, right? That's about it. Right? Super Heavy is that. It is a completely different design. It bears some passing resemblance to previous versions of Starship. This is a new pad, new engines. New pad, new engine design, new booster design, new tower design, new disconnect design, new chopstick design, new catch point design. Like, there is nothing in common with previous Starships here. The only thing that they have in common is that they're both made out of stainless steel, and that's about it. Do they still use the pad? Okay, I already answered that. Having a proper igniter would surely cause a very accurate ignition at a specified time. Relying on acoustics could potentially allow for the mixture to enter the chamber and pipes before the mixture ignites. That was my thought, Lava. That's actually what I was thinking about. I was thinking that with an acoustic igniter... Okay, so with an acoustic igniter, you are beholden to flow rates in your pipes, right? And if the flow rates are even a millisecond off, you know, between like one ignition happening over the other, you could have a big problem. So Lava, I gotta think, you know, SpaceX style, if we're gonna nerd out for a second, what would I do? I would make it so your acoustic igniter only goes when you have full pressure in the downstream lines from your turbo pumps, from your power heads to the main combustion chamber. So I would mount this igniter would be somewhere on the injector plate, right? But even then, you're still subject to potentially slight millisecond deviations in ignition, right? Right? Am I thinking about this correctly? Because it takes a second to saturate the injector plate. Now, with something like Raptor that's a full flow stage combustion making 300 plus bar chamber pressure, I'm not sure you have to worry about it. You could still potentially be open to a nominal range of a couple milliseconds between your call for ignition and the actual ignition happening. But yeah, that's where my mind's going, dude. It's good that they are testing kind of like this so they can actually say that the diverter is good, looks cool with you, though. Okay. Yeah, I mean, I've been saying this for a little while now that this needs to be incremental testing. You're gonna need to take baby steps with this. SpaceX actually has to slow down. Now, I had a lot of arguments with chat about this in the past, like from Space News is from like about a year ago, about whether SpaceX should accelerate in the face of like the Flight 7 and Flight 8 failures. or if they chat was a lot of folks in chat were saying that they should back off a little bit. Well, I would say that the people in chat were correct about that, but for a different reason than you think. The chat was saying that back off and go slower and do more incremental testing with your boosters and your starships to get your flight reliability up. But what I always argued is that with the Block 2, it wasn't about flight reliability in the first place. That's very much a huge test article, and that your flight reliability would come from the lessons learned from flying. It was kind of not what I said and not what they said either. SpaceX ended up slowing down because they refactored the entire booster design based off of what they learned through I would actually say probably through the first 6 flights of Starship, if I had to guess. I think the Block 2 Starship part of the program, so late 2024, basically to the end of 2025, was just getting rid of architecture that they knew wasn't going to work, so they could get some data on thermal protection system, reusing potential super heavies, chopsticks, catching stuff, etc., etc. And I think they're going slow now because they refactored the entire design. So I think it was a little bit of column A, a little bit of column B in retrospect. But yeah, I've been saying that incremental steps are probably the right move here, especially new pad, new booster, new engines, new everything. Baby steps right now. That'll make it so, you got to crawl before you can walk, right? That'll make it so, later you go from crawling to walking to running. Check Baron's link. Oh, Baron's here? He was the person I was arguing with a year ago. I want to talk to you. You suck. No, what's up, man? What do we got? I'm just messing with you. I'm just messing. Sorry. Sorry. My New Englander came out there for a second. Okay, so this is coming from Space Engineer. This is coming from my boy here. I like Space Engineer. That guy's super cool. Enough information now to see a potential caveat of the startup process. If you look real close at the video of the firing today, you see an initial small flash about a second before the engines actually light. We saw this during the igniter test yesterday as well. I'll link it in the replies. The timing is right about the same as the tiny little spin start discharge we have seen from videos at McGregor. The video in this post. The interesting thing is obviously that on pad 2 this discharge is igniting on its own. Not sure why it's igniting like this, but it does confirm the usage of gaseous oxygen and gaseous methane to spin up the respective turbines, opposed to nitrogen previously used by R2, given that flash is even possible. Go figure that fire suppression is really needed now. I hate you too. All right, cool. Let me see what my boy's saying here. Is it possible that that's an acoustic igniter? Okay, I'm not trying to teach you guys anything. Nerds, let's nerd out. Is it possible that residual ignition that Space Engineer is talking about is the acoustic igniter? This is a clip of test footage from SpaceX showing off some Raptor 3 firing. EJ, but the next day's road closures were revoked. Interesting. Sounds like they just deleted the nitrogen system. If I recall correctly, there was only white gas coming out of the nozzle before ignition on Raptor 2 and Raptor 1, so maybe. Interesting. And I'll be honest with you guys, I appreciate learning this stuff with you as we go, because I'll be okay. Here's the real honest to God truth. I had no idea what an acoustic igniter was until about 12 hours ago. I'm like, dude, I am not even going to sit here and pretend for a half second or even a millisecond per ignition, like on the engines that we saw, that I'm going to sit here and be like, oh yeah, of course I knew what that. No, I did. I thought Raptor 3s were using torch igniters until about yesterday. Yep. So I'm not like too incredibly like I'm not ashamed to say that I didn't know what that was. We didn't know until we saw it. And that feeds to how tank watching works, dudes. Like we NSF and Alex and all those other guys and me and you, like here in chat, we ended up learning so much because we watched so many damn tests, right? Like we watched so many of them that we eventually figured out how stuff works, right? That's how guys like Space Engineer and all these other dudes out there, like so Ryan Weber, like Space Engineer, Zach Golden, that's how we figure this stuff out. We sit there and we watch what they do and we use what we know about rockets to extrapolate that information, right? I'm not ashamed to say I didn't know what an acoustic igniter was. But the second somebody mentioned it to me, I'm like, oh yeah, okay, that makes perfect sense. And I know enough about rockets to be able to explain how it works. Actually, you know what? With that all being said, let me get my rocket engine book out here. I want to see if there's anything about acoustic ignition in this thing. I'm just genuinely curious at this point. So this is modern engineering for design of liquid propellant rocket engines. Let's take a look. For the people that don't know books, I'm going to go into this part of the book at the very back. It's called the index. And it's basically an analog search bar. It's an analog search engine, okay? I also hate the paper cover on this thing. Anytime you open the book, it wants to come off. So we take the paper cover and we put it in a very happy place over there. So let's go to A. I got my reading glasses on. There's acoustic cavities on 106 and 132. Let's try igniters first. Shh! This is a library. Igniters. Okay. Here's the subsection. Augmented spark igniters, capacitor discharge, catalytic igniters, combustion wave igniters. Let's think about that one. Direct spark igniters, flame spreading, the A4 engine igniter, hypergolic pyrotechnic, reliability, requirements, resonance, spark plug, spark torch. I'm going to go ahead and guess combustion wave is, well, no. Combustion wave would be done post-ignition. Let's try resonance, 125. Figure 4.7, a resonance igniter. Resonance igniters use a flow of pressurized gaseous propellant to create resonant heating that will start the igniter propellants. Oh. Resonant igniters use a flow of pressurized gaseous propellant to create resonant heating that will create resonance heating that will start the igniting process. So you'd use a gas tap off. You'd use bleed, or in aviation airplane terms, you'd use bleed air. But it's not bleed air because you're bringing your oxidizer with you. So it would be a tap off. Resonance igniters use a flow of pressurized gaseous propellant to create resonant heating that will start the igniter propellants. Igniter exhaust, with or without oxidizer augmentation, is directed to the injector face, where it is used to ignite the main propellants as they enter the combustion chamber. Lava, that's what I was saying, dude. It has to, if you're using a resonant or an acoustic igniter, it has to be at the plate. You would not want it in front of the injector plate. That would be very bad, because the injector plate's what's going to give you your atomization for combustion. It would have to be downstream or at the injector plate. Hey, Rosebud, $10 super chat. Thank you. Here's another sign that something went wrong. Wrong? Oh, that's a chine vent, dude. That's supposed to be there. Yeah, that's supposed to be there. Good eye, though. Those things definitely were going. All right, let me see. The igniter consists of basic elements shown in figure 4.74. It does not require external electrical power or catalysts. Gas introduced from an elevated pressure source upstream of the sonic nozzle expands into the mixing chamber and is directed into the resonator cavity, where it is cyclically compressed and expanded. This raises the temperature of gas at the closed end of the cavity. An additional amount of gas spills directly into the mixing chamber, and it is exhausted from the igniter. Temperatures of 2,000 Fahrenheit, which is that's like 2,000 Fahrenheit is, I think it's like 1,100 Celsius. I think that was a guess doing 1.8 32 hike. Temperatures of 2,000 Fahrenheit have been generated with 60 ms of within 60 ms. Whoa. Temperatures of 2,000 Fahrenheit have been generated within 60 milliseconds with gaseous hydrogen. After the fuel in the cavity has reached a sufficient temperature, oxidizer is introduced at the hot zone to effect ignition. The concept can be used with propellants other than hydrogen and oxygen, and with premixed propellant combinations. Several variations of the resonance cavity design have been tested, including flow-through designs, which heat gas for subsequent injection into a combustible mixture, or for an injection with a second propellant to create a combustible mixture. Holy crap, dude. This is some really... If those were words that, some of you are like, damn, that's cool. And I can see it. I can see it through the camera. Everybody else is like, yeah. Yeah, that sounds great, man. And some people are just like, yeah. Let's see. This is some real rocket science. It sounds like SpaceX upped the compression ratio on the Raptor. Compression ratio? And taking a page from Rudolph Diesel. Well, that's essentially what this resonant igniter is. It seems to be a gas tap-off device that superheats your gaseous fuel to a high temperature and then shoots oxidizer into a compressed chamber where the gas is at high pressure. Yeah, that's a turbo diesel. Yeah, that is what a turbo diesel engine absolutely does. Yeah, that's what a turbo diesel does. Like, that's what a 6BT Cummins with a gigantic Nagasaki noisy boy on the side does. It's the same thing. But this is using it to, so like with rockets, guys, unlike a car engine, let's take a gasoline engine. A gasoline engine, you need a spark plug. The piston's going up and down. You need a spark plug going off every time the piston completes the 4-stroke cycle. You need it during the power stroke. So a spark plug goes off halfway through the 4-stroke cycle. It goes off at the end of stroke 2, but the beginning of stroke 3, right? With a diesel engine, you don't need to do that. With a diesel engine, you force air at high pressure into the piston's combustion chamber. The piston starts to come up, and then right as the piston is coming up, the fuel injector on the diesel shoots off, and it shoots diesel fuel into compressed oxidizer. And the result makes a gigantic explosion. The reason why is because the oxidizer gases get hot because of the ideal gas law. All right, so I'll get into very basic science here. There's this formula called the ideal gas law. It's PV equals nRT. What that means in plain English is that if you compress gases, they get hotter. If you decompress gases, they get colder. If anybody here has ever fired a paintball gun, Fire a paintball gun, right? The canister gets really cold. Or if you've used a propane heater, you open up the propane heater, you turn the heater on, the propane tank gets cold. There you go. Propane is a gas. Inside of a paintball gun, you have CO2 or just, atmosphere. It still is a gas. It gets cold. That's what it says. So in a diesel engine, right, the piston is going to come up and it's going to compress the air that was forced in there from the turbo, right? And that air is going to get extremely hot. And then if you spray fuel into that extremely hot mixture, it'll auto combust it. It'll blow up. That is exactly what this is. What these acoustic igniters or resonant igniters are. It's probably one or the other. Yeah, I would guess that SpaceX has some kind of tap-off system in the Raptor's design. I would look... Yeah. Diesel from a high-pressure pump hurts when it goes into your eyes. I would... Do I want to know how you know that? Do I want to know how you figured that out, Wisp? Do I really want to know? I don't want to know. So it's like an NHRA top fuel nitromethane with a supercharger. Oxidizer comes in with the fuel. Yeah, it's more like a diesel, Scott, but yeah, with nitromethane, sure. Yeah. Can we get a picture of the Raptor 3 plumbing for a moment? Yeah, okay. Raptor 3 plumbing. I know that Space Engineers said I could use this picture because he was here the last time I showed it. He has a thing about it. Where is his schematic? I know he has a good one. Creeper, where's TSE's schematics for the rock? Not schematics. They're not a schematic. I know he did a damn good render. So this is from JWL or HVM on NSF here. This one will work for now until we find Space Engineers renders. TSE's render is fantastic. Actually, you know what? That's not going to work for my explanation. Oh, I found it, Creeper. Yeah, I got it. Here it is. So the Space Engineer, same guy that made that post that we were just looking at. Check this out. So let's take a look. So this is pretty updated. This is from about a year ago. It is subject to change, obviously. From what I gather, the incoming velocity high-pressure fluid acts as a piston for lower velocity, similar pressure inside of a cone and creates conditions required for ignition. That's essentially what this says, dude. Yeah, that's the idea. If you look at the diagram, take a look. Yeah, Hellfish, you link that paper. Look, that's what that is. See what I mean? It pressurizes fuel in a cavity, and when the pressure gets high enough, it opens up a valve, and that sprays the oxidizer in. It's all passive. No, see, knowing SpaceX, they're probably not using valves in this particular part of the design, but I could be wrong. What was the name of said book? The Bible, dude. Modern Engineering for Design of Liquid Propellant Rocket Engines. Remember, even if you don't want to get into... This is a college-level aerospace textbook. Even if you don't want to, like, build your own damn rocket, this is still cool to understand if you're a tank-watching nerd. Rocket science is pretty straightforward and easy to understand. It's hard to do. It's hard to do it. It's hard to do it. I can teach anybody how a rocket engine works. It shoots hot gas out the back. It's not complicated. Doing it is the complicated part. Getting it to do that without blowing up, that's the hard part. You know? It's interesting. We found it in here. But it's called a resonant igniter, which is interesting. So let's look. We're in space. Like, this is Space Engineers. This is a fan. Space Engineers just, he doesn't work for SpaceX. He's just a fan of he's just a nerd like we are. Probably a bigger nerd than most of us. Probably me at this point too. Where would we get high pressure? We need high pressure gaseous methane, right? And we need high pressure gaseous oxidizer meeting each other at some point that will allow for turbine actuation. See, I theorized that if you have any type of igniter, it's probably somewhere in this area right here. Yeah, exactly, Ethereal. Hey, Galax, what's up? The igniter should be in the pre-burners only. See, that's why this is very interesting. I said, Phil, that so we've known in the past that Raptor 2 is using a torch ignition system. Torch igniters happen in the pre-burners, right? But if they've truly switched over to a fully acoustic system, we need to find a spot in the pre-burners where you have hot gas, and hot fuel, and hot oxidizer gas. And I'll be honest with you, I'm noticing several points in this design where you actually do have that. Someone did this link before, but you haven't checked it out. I'm trying to cover one thing at a time, but you guys want to see this right now, so you see this right now instead. Huh. Good old ANSYS. Got to get you to come out to the NHRA Diesels in the desert event in Phoenix next year. Bring your 7.3. I don't have a 7.3. I got a 5.8, man. If I'm putting a diesel in that 97 Relke, it's going to be a 6BT. I'm putting a Cummins in there because the 6BT in the Ford OBS chassis is the best, is the combination of all the best stuff of the 90s. Now, if we're talking a gas engine, big block Chevy would be pretty cool. Or a 460. Either one. Yeah, no, I see. It shoots hot gas into this cone, and the gas reverberates. And because it reverberates at high pressure, right? Because it's, you know, gas is getting compressed, it ignites. And the resonance wave gives you, it reverbs and causes combustion, right? There. Interesting. $8 here. Attaboy, Rob. Attaboy. So my question is, I mean, Space Engineers manifold is pretty damn good, or diagram is pretty damn good. Where the heck would you do this? My mind is immediately going to here. $12 or $24, both good. I like old stuff. I like the 12 valve. 12 valve will do me just fine, farm. 12 valve with a big old turbo on the side. Don't worry. I have plans for the 97. That's all I'm saying at this point. I have plans. We got to finish this steaming pile of Dodge, though, in the shop before we get any further. We gotta get some work done on that. Right there, pretends to point in the screen. Oh, that's a good spot. So you think they're using the pre-burn exhaust to light off the engine? Yeah. "12 valves of the P-pump hold their own on the drag strip against 6.7 common rails." Agreed. That's exactly what I want. 12 valve P-pump. You got to work on the dowel, right? You got to do the dowel and then torque the head, and there you go. Holy crap, it's anti-lag. Yeah. Wait a minute. Whoa, hold up a second. Do you guys remember? We were watching a McGregor live one time and we saw SpaceX immediately start and stop the Raptor engine. This was probably like in 2024. And we had theorized, Hellfish, that they are using some type of anti-lag system to keep their turbines spooled up, right? So they can quickly start and stop the engine. Well, a resonant igniter would definitely do that. If employed correctly, yeah. If you did that right, you could definitely do that with that, yeah. Dowel head studs, injectors, turbo, 1,000 horsepower. Ugh. Okay, I gotta finish the Coronet so we could do other cool stuff with the trucks. Yeah. But yeah, the dowels, you gotta do the dowel. I know that. I've never wrenched on a Cummins, but I know about the dowel. Oh, don't you worry, I know about that. Yeah, you don't want that. You don't want that happening. That's bad. Huh. Yeah, guys, I'm thinking, so where are you going to have highly compressed gas? So you have your impeller here. Your impeller is past your main fuel valve, right? MFV. Then it goes through the copper channels on the Raptor, right? And then it pops up here, right, as gaseous methane. The gaseous methane taps into two spots. One tap off is for the stage combustion cycle on the methane side, or on the oxidizer side, and the other one goes right into your fuel pre-burner. That's where I'd have the igniter, right there, on this manifold instead of the main one. Interesting. Yeah, that's where I'd put it, right there. Because you can trickle fuel with your main fuel valve in here, get your methane to heat up and make pressure in this line. You can make pressure in that line, and what do we know about a resonant, and what do we know about that resonant injector? What does that thing do? Oh, wait, it creates pressure, heats up gas. Remember that whole part? We were just talking about that a second ago. And if you start to drive your fuel pre-burner, right, it'll start shooting stuff through the hot gas manifold, right? But also, check it out, your gaseous methane will feed up here. It will feed your oxidizer turbine as well, because you have an injector up there. But what is that? What is this? Hold on. What's that red? Right there. What's that coming from? That's a hot gas. hot gas manifold. I mean, it makes sense. It's right there in front of us. You have a hot gas manifold. You have mostly liquid methane, and then you have oxidizer coming through your fuel, your oxidizer impeller. Both are cold, actually. What do you mean? So this hot gas manifold right there. See, am I looking at that right? What is that the same? Is that even the same color? No, it's not. It's not exactly the same. What is this? This guy right here, this red-ish. Looks red to me. I don't know. You guys say. This thing. Oh, I see. It's your igniter. There it is. That's it. I'm looking at it. It's been in front of me the entire time. There it is. Hot gas mix is right there. And then, yeah, there and there. Done. Makes sense. Makes sense. They're at the right spots. You'd have to do it where it would induce atomization, and we know that they don't have one on the main injector plate, so it would be on the preburner injectors. There you go. I don't think it's an epiphany, and I don't think we discovered anything that like Space Engineer or anybody else didn't know, but now we know, so that's good. So we got that going for us, which is nice. You know, that's pretty neat. How neat is that? That's pretty neat. Also good to know that certain types of resonant igniters can operate for many seconds. They kind of act like a self-igniting oxyacetylene torch. Yeah, well, it's using auto combustion. Like I said, that's not that. So lava, that's how every diesel engine works. First of all, every diesel engine uses this operating principle. Second of all, that's SpaceX to a T. Yeah, use passive fluid systems to create your auto combustion for you. Or to create your ignition for you. That catching rocket clip behind your head makes head look so made up, but it's real. Dude, you have no idea. I've seen things you people wouldn't believe. No, here. You want to see something cool? I have another angle of it that my buddy shot when I was down there. You want to see some cool stuff? Look at this. This is a Flight 7. Now, this ain't exactly what I want to show you, but Pugwash, watch this. It's also good to know that certain type of resonant... Okay, I already did that. All right, gotcha. All right, now watch this. So, you know, that's Starship, this Flight 7. Yeah, that's all good. This part. Headphone users, this gets a little loud.
Come on. Here we go.
That's me and Gene Rowley in the... calling this. I agree, Aqualux. That's SpaceX to a T.
Come on. Do the thing. Do the thing. Yes. Come on.
We're seeing some vapor on it.
Oh.
Come on, baby.
Come on. Light it up. Yeah.
We got a light.
It's coming down. It's coming down.
Come on.
Oh, it's slowed way down. Down to 3 engines.
Come on, bring it on home.
Just dancing over there like it's nothing.
Come on, baby.
Yes!
Oh my
Yeah, that's pretty cool, huh? That's pretty neat. Dude, the reason why I'm not talking a lot in this is because my brain is still, to this day, like, I still see it. I'm like, huh? Dude, that is some Halo ODST sci-fi stuff going on right here. This just. Oh! When it punches through the clouds, man. Oh, that is pretty good. How's Gene these days? He's doing all right. I haven't talked to him in a little bit, but yeah.
Fly, baby, fly.
That's all I managed to muster. Fly. Just fly.
Do the thing. Yes, come on.
Seeing some vapor on it.
Oh, sorry, Rose. It's just Nightbot. It didn't like it.
Come on, baby.
Come on, light it up. Yeah.
We got a light.
It's coming down, it's coming down.
Come on.
Oh, it's slowed way down. Down to 3 engines.
Come on, bring it on home.
Just dancing over there like it's nothing.
Come on, baby.
Yes!
Oh my. Oh my goodness.
Yeah. Yeah, that's pretty good. My brain still has trouble understanding what happened there. Like, I saw it. I saw the thing come down. Like, I saw it land. I'm just like, what? How did you did that? That's pretty neat. Yeah, that's pretty cool. Yeah. Yeah. Yeah, that's pretty good. Is Gene still a part of NSF? Yeah. He's around. Yep. Yeah. The vapor clone's actually insane. Yeah. John was actually standing next to us, Conan, when he took that picture. Yeah, he was standing next to us. Yeah, Kraus was there. Did it pop on shutdown, or was it just a spicy honk? We were too far away to hear something like that, Kralani. Yeah, maybe it was a squawk. Little squawk, and that's about it. But yeah, interesting stuff. Resonant igniters. Excellent camera work. That was done by Erebors, who does work for NSF as well. Erebors is a very, very good cameraman. Let's just say that, and we'll leave it at that. That's when I asked him, I'm like, "Can I say what you cameraman?" He goes, "No, just say I'm a good cameraman." He didn't say that, but that's the idea. Yeah, he's a good cameraman. We've established this. A really good one, actually. No, Erebors is awesome. Yeah, he's a good dude. Good friend of mine. He's a good cameraman. All right? We have top cameramen working on it. Which ones? Top cameramen. If I'm ever in the U.S. for any reason, you bet your butt it'd be solely watch a Starship catch and launch. You should see it at some point. It's show it again. Show it again. Okay.
Yep.
All right. We can have it your way, Dr. Bankman.
Fly, baby, fly.
Come on. Do the thing. Yes, come on.
Seeing some vapor on it.
Oh,
Come on, baby.
come on, light it up. Yeah.
We got a light.
It's coming down, it's coming down.
Come on.
Oh, it's slowed way down.
Those 13 engines going full blast.
Down to 3 engines.
Come on, bring it on home.
Just dancing over there like it's nothing.
Come on, baby.
Yes!
Oh my
goodness!
Let's see if we can hear the honk.
Yes! Whoa!
Yes!
Whoa!
My goodness.
Oh my goodness! I know I'm sick.
Oh my gosh.
Oh yeah, Das was there too. Dude, yeah, the sonic boom. Yeah, if you guys have never seen one of the Falcon 9 or a Super Heavy land, usually the boom happens right after it lands, or just like a little time after. I remember I was at the first Falcon 9 landing. I was down in Florida when that happened. The first landing ever of a Falcon 9. The first successful landing, I should say. And everyone thought it popped because right when it landed, the sonic booms happened. And I remember I was with a bunch of NASA engineers and they were like, yo, it exploded. I'm like, no, it didn't. That's the sonic boom. And then the smoke cleared and it was still there. And yeah, then we had a lot of beer that night. That's the end of the story. Yeah, that's the end of the story. Yeah. Yep. Can you explain why there are so many sonic booms happening? I understand the one, but why others? Okay, 619. So sonic boom is correlative to airspeed, okay? It's quite actually how fast something is moving past something that's flying through the air. Now, with that being said, so think about a wing. What does a wing do? Like, think about Bernoulli's principle, all right? A wing has air on the top moving at faster speeds at low pressure, and then you have air on the bottom of a wing moving at lower speed at high pressure. Differential airspeed is what causes, well, it's mostly pressure, but you get the idea. That's what causes lift. That's Bernoulli's principle in a nutshell. So, therefore, anything that flies through the air, kind of by default, has different points where the air changes speed. And this is why, like, supersonic, like going supersonic is not a set number. It's, you enter what's called the transonic regime. The transonic regime is from 0.8 Mach to about 1.2 Mach, right? And what that essentially means is that there are parts of the vehicle breaking the sound barrier, and there are parts that aren't. Because Mach speed is indicative of airspeed over a certain part of the vehicle. So, you know, like if a plane is flying in the transonic regime, there are parts on the aircraft, like on the top of the wing, that are going to break the sound barrier before the bottom part of the wing because of differential airspeed, right? That's basically what transonic is. Transonic is when some of it is breaking the sound barrier, or air is moving over some of the vehicle at a speed fast enough to break the sound barrier and cause a sonic boom, and there are parts where it isn't. Now, the double sonic boom happens from the bottom of the booster, so where the engines are, breaking the air, and then the top of the booster breaking the air, because that's where the airspeed is. Like when the booster was coming back down and decelerating, those are the points where air was getting accelerated the fastest. It happens generally around areas with low pressure, with low pressure and higher airspeed, like what I said on the top of a wing. Right? Now, there's a bunch of other things that play into Mach speed. It has to do with altitude, atmospheric pressure. It has a lot to do with humidity. Humidity makes a big difference because if there's water vapor in the atmosphere, right, if there's water vapor in the atmosphere, it kind of changes how you fly. It can change the temperature. It can change a bunch of things. But yeah, that's essentially what transonic means, and that's part of the reason why you hear certain sonic booms from different parts of the vehicle, and not one overall big sonic boom, because they're coming from different parts of the vehicle that are still going supersonic at the point right before landing. Does that make sense? Yeah, that's why it's called transonic, and that's why there's not, like, the sound barrier isn't 768 miles an hour on the dot. Like, that's not really how it works. It's kind of a nominal window. Generally, past 1.2 Mach is when the entire vehicle is going faster than the speed of sound. The aviators of knowledge. That's right. Booster transport stand is on its way back to pad 2, so D-stack either to work on it or most likely to roll it back. They're probably going to roll. They're probably going to roll. which... So Ship 20, another thing regarding Starship, if they're willing to move the booster back this quickly, that tells me that what happened this afternoon was an induced test and it did what they wanted it to do. If the booster exploded and something weird happened, they would probably be a little bit more cautious about moving the dang thing, especially if something broke, right? Think about it like when Booster 18 blew up on its test stand. They didn't just roll the freaking transport stand out there, pick up the hulk of that thing and try to put it on the transport stand and get it away. No, they scrapped it in place, right? I mean, Booster 19 testing today is not Booster 18. Those are two different things. I understand this, but that tells me that whatever we saw today was an induced test and it was on purpose. You guys, a lot of people have speculated that it is about putting the pad through its paces, which does make sense. The shuttle made twin sonic booms from the nose and from the tail, from the rudder. Yeah, that's where it made sonic booms, because at that point in its regime, the way it's flying, the air moves up over the nose and hits the top of the tail. So you heard the twin booms from the shuttle, from the tail and from the nose. Deep Space Weasel! Welcome to Mission Control. You're going to throttle up. We're going to give you your ceremonial... Hey, congratulations, Deep Space Weasel. You have got the gold medal at the Olympics. We are going to give you a ceremonial weasel and rat. Here you go. Here's your gold medal. Enjoy. This is the ceremonial weasel to represent the plight of the Italians of Milan. Did anybody else understand that? Why were they handing out weasels? Here's your ceremonial weasel. Enjoy it. Love it. It is just as important to you as your gold medal. Ceremonial weasel. So why not? All right. Yeah, that's fair. Here's your medal and Beanie Baby. Yes. Anyway, thanks for the subscription, man. That's good stuff. Thanks, buddy. All right, guys. Well, that puts our space news here. We started it at 4:30. It's now 7. So that puts us at 2.5 hours of space news. I think that's... Nate McKinnon about ripped its head off. Wow. It had 2. There was 2 animals on it, Fluffy, so he would have to, you know, rip off 2. Number 2. You know they lost in the Paralympic game too, right? You know they lost in the Paralympic game too, yeah? Just saying. Who does number 2 work for? Canada, apparently. Thank you for the education and the laughs. My pleasure. Any recent news on the Bluebird Block 2 on New Glenn for Flight 3? Nothing. I know that Lorgen has a lot of Lorgen has a lot of upper stages in the pipe, but yeah, nothing. Doesn't wearing... They're over-the-ear headphones, Bob. So no, it's fine. Rocket Garden at Starbase, you could see this from the public highway. No, you can't, because there's only Ship 20 there and an old booster. Yeah, Blorgen. Blorgen and Newglands. Yeah, see, Jack's on it. He's got it. Yeah, see, Jacques Boyer. He knows. He's a very, very, very successful French explorer of the high seas. Jacques Boyer. He explores the asteroids. Might be a bit off topic, but have you seen Project Hail Mary? I have not. I have not. Okay. Well, have you read it? I have not. Not because I haven't want to. Do you plan to? You should. I have not planned to, no. Man, Dave Plummer's just posted more awesomeness. You know. Okay, yep, that's really loud. Sorry about that. Yeah. Yeah, this is your moment of zen for ending space news. Yeah. Yes, very nice. You see he's AIing Robotron. I did see it. Holy shnikes, dude. Ow. Why does it do that? I just want to pause the video. I don't need the sound to play, Elon. Jesus. Dude. Big block 4-speed car. That's pretty nice. Well, that's pretty neat. Yeah, look around, guys. That's what the Coronet interior is going to look like when we're finished, only it's going to be blue. It's going to look about that, complete with crappy fake wood grain. It's going to be great. Bro, does any automaker have the stones to do a bright freaking red interior? I don't think so. And it's not a Pontiac? Oh, it's a Pontiac. It's just the Canadian Pontiac. But it's not a Pontiac either. It's a Chevy with Pontiac emblems on it. But it has a Pontiac engine in it. Oh, I've seen his video about it. I know exactly what this is. Very nice. Yeah, it's funny. To circumvent Canadian import laws on American cars, the Canadian government in the 60s wanted GM to make stuff in Canada. So what GM did was just ship over some of their most popular like models of cars in pieces to Canada and built them there. But they couldn't be the same car. They couldn't be the same as their American counterparts. So they took like an Impala and put Pontiac badges on it. Right, gotta go. Thanks for the stream. Yeah, Dave Plummer actually has a whole video about that, which is super cool. It's extreme autism car nerdery, and I love it every second of it. It's amazing, actually. Your audio is a half-second delayed. I don't think it is. I don't think it is. Try refreshing your browser. It's showing pretty good latency on my end. Bums me out that our Heritage Center isn't open. You'd curl up in the fetal buttering and drooling like I did. Yeah, probably. Audio's good. Thank you, King Kitten. All right, so, fellas, here's the deal. Let's, to cap off space news here, let's check to see what we got for flights. So, in 4 hours, we got Starlink 1724 from Vandenberg, but I may or may not have signed up for this Starlink mission for NSF, so I might need to skedaddle. The other thing is that there is a disgusting storm going through my area right now. I can hear it. It's really cold and really windy outside. So yeah, fellas, listen to this. Hold on, let me shut the noise suppressor off. Listen to that. It's very chill, but also that's a pretty bad storm if we can hear it like this. It was 70 last night where you are, Mutter, and it snowed this morning. You know. So, here's the thing. Yeah, I may have signed up for that, but the caveat to that is that I told Chris B that I might not have power in the morning because we're going to get extremely high wind gusts through here. So wind is so bad through the Four Corners these last 2 days. Yeah, farm. The wind out here has been disgusting, dude. Like 60, 70 mile an hour winds. It's ridiculous. And it's like every day, dude. I'm like, can we not wind, please? So here's the thing. I am, dang, I missed Space News. This storm is nuts. I had to secure our pool cover. Oh, crap. All right. It shredded your Harley coverage. Jeez. Okay, so here's the thing, guys. I am going to take the rest of the night off, not because to get sleep. I'm going to take the rest of the night off to make sure my house doesn't get blown away. Yeah, that's probably a good idea. So if I do have power in the morning, I will see you guys at basically 6:30 for that Starlink mission for NSF. And then what I think we'll do is tomorrow we'll do a nice long stream. If I'm doing that Starlink mission for NSF early in the morning, right? And then we might potentially have tank watching in the afternoon, depending on the rollback or whatever. That's getting absurdly loud. I think we'll work on the car tomorrow. We'll work on the car, do some tank watching, and play some KSP. We have to get that rocket, that direct rocket, all figured out. So, yeah, I'm gonna go batten down the hatches. That's what's gonna happen. That's a good way to say that. Batten down the hatches, and we do not need to swap the poop deck because it's raining. I want KSP streams, and I want a toilet made out of solid gold, but I'm not gonna get one now, am I, Blark? No, we'll get KSP tomorrow. Okie dokie? I mean, I really don't want a toilet made out of solid gold, but that'd be kind of cool. All right, who's out and about streaming right now? And oh, my buddy Duke's streaming. Let's go see what Duke's up to. On the YouTube side of things, I'll see you guys later. Let's go see what Duke Euphoria is up to. He's a good dude, good buddy of mine. We'll raid him. Duke is the highest of the highest nerd of software, of the software engineering type. He's a good dude. Go raid Duke, and I will talk to you guys all. So, once again, if I have power, I'll see you here earlier in the morning. If not, I'll talk to you whenever I get it back. All right. Or get the generators running again. But we'll see. Either way, I'll see you guys tomorrow. Thank you very much for watching. That's going to do it for the stream today. Have a good night.